Hello, this is Rosario Rossini from University of Torino. In this interactive system preview, I will provide an overview of the STFMap system for query and feature-driven visualization of time series datasets. STFMap has been developed by myself and Professor Maria Luisa Sapino from University of Torino and by Xiolan Wang and Professor Sergio Canna from Arizona State University. STFMap is built based on the key observation that time series data often carry structural evidences in the form of sudden temporal features, and these can help users quickly focus on the relevant portions of the datasets. STFMap leverages this observation to include 4 novel temporal time series dataset visualization techniques: segment maps, warp maps, stretch maps, and feature maps. This is the main guide of the STFMap system. The first action a user performs is to select the dataset for exploring. Here I will select the GAN dataset, which is part of the UCR time series classification and clustering collection. There are 50 time series in the dataset, and the length of each time series is 150. Once the dataset is selected, the system visualizes the time series in the set using 2 alternative visualizations. The XY plot-based visualization at the top, where time is plotted on the x-axis and amplitude of the series is plotted at the y-axis, is a commonly used visualization scheme from time series. But, as one can see, the visualization gets overloaded very quickly with crossing of plots. In the heat chart at the bottom, each time series is plotted as a column. Blue indicates the low amplitude points on the series, and red indicates high amplitude points. As you can see, this heat map eliminates crossing and can help the user select a time series of interest more easily. Here, I will select the time series 17 for further exploration. The STFMap system shows me the time series selected, as well as significant features identified on the time series. The stars on the timeline show the centers of the identified temporal feature, and vertical lines show the segment boundaries where a feature starts or ends. The segment map visualization interface, which I selected now, creates a heat map similar to the one we have seen earlier, but including segment boundaries for all time series in the dataset. The case that, instead of showing all features and segment boundaries, the segment map shows only the features and segment boundaries consistent with the selected time series number 17. In other words, the selected time series is used as a guide for segmenting all the time series in the dataset. Note that it is also possible to sort the time series based on their similarity to the series 17 and roll up the segments to have a lower granularity view of the segment boundaries to have a general idea about the feature distribution of the datasets. Now, let me select feature 53, which is right after the first significant jump in amplitude on the selected time series 17. The second visualization interface is the warp map. Here, the query series 17 is plotted with colors changing from blue for time equal to 0 to green for time equal to 75 and to red for time equals to 150. Also, each time point on each data series in the dataset is painted with the color of the corresponding time point on the query series. In this example, on each time series, the system also highlights the point corresponding to the selected feature of interest. Time series are ordered left to right according to their similarities from the time series 17. As the plot shows, similar time series have a smaller amount of warp, and the matching segments are better aligned. Different series involve more warping both in the overall series and the boundaries of the segment contain the feature of interest. Alternatively, the warp map can also be created in a way that series are ordered based on the positions of the features mapping or features of interest. The time series 17 is also highlighted within a red box. Time series is to the left of 17 have their big jumps earlier, whereas the time series on the right have the jump later. A stretch map is similar to a warp map, but is designed to help the user focus on the major alignment differences more quickly. See the red and blue regions on the stretch map I just created. Here, the more time series need to be stretched backward to align it with the series 17. The darker is the blue shade. Similarly, the more the time series need to be stretched forward in time, the darker is the red. Green shades denote no stretching. Finally, I will demonstrate the feature map tool, which helps the user to directly explore the dataset based on the feature of interest. Here we see the feature map of the GAN dataset created based on the feature 53 of the dataset 17. Here, darker red indicates better feature matches and blue shades indicate poor matches. The series are ordered left to right in order of best matching feature, and on each series the boundaries of the best matching features is aligned. This visualization helps user quickly observe the position of the likely matches of the feature of interest. Thanks a lot for your interest. You can contact me by mail for any questions and comments about the STFMap time series dataset visualization system, as well as the underlying SDTWI algorithm for identifying robust features of a given time series.